All right, guys, so what we're looking at today is more matrices. We're looking at more matrices today. Now, first thing we're going to do is determine the order of the matrix, and that's just really the dimensions for any of these here. So if we look at A, if we look at its dimensions, it's rows by columns, down and over. So we have 2 rows and 3 columns, so we call this a 2 by 3. Now for our second matrix, the number of rows we have is 1, 2, 3, 4, and our number of columns is 1, so this is a 4 by 1. Now the next one is indeed a 3 by 3. Specifically, we would call it a square matrix because the number of rows and columns are the same. The one before it would be considered a column matrix because it has exactly 1 column. And the last one is a 1 by 3, and this would be considered a row matrix because it has exactly 1 row. Any questions on any of these here? Now we've done these in Algebra 2. We also talked about elements because each number or variable in the matrix is considered an element. And we denote it in lowercase. So if we call the first matrix here matrix A, so A is 3, P, 1.7, negative 1, 6, 10. Each of the numbers and elements in here we could call by, say, A1, 2. A1, 2 would be first row, second column, which would be P. So we can consider each one of the spots in a matrix as an element. And we denote elements as a lowercase of the matrix. So matrices are normally defined or called by capital letters, and their elements are lowercase. Now the first thing we're going to do is find addition or sum or difference, addition, subtraction. Now to be able to add or subtract 2 matrices, they have to have the same dimensions. They have to have the same dimensions. So if we look at part A plus B, we're saying that we're taking matrix A, 3, negative 7, 0, 1, 4/3, negative 6, and adding to it matrix B, 8, negative 3, 4, 0, 1, negative 9. And whenever we add 2 matrices together, we add their corresponding elements. So the first row, first column will be added to the first row, first column. So we'll do 3 plus 8. Then we'll have negative 7 plus negative 3. And lastly, in the first row, 0 plus 4. In the second row, we'll have 1 plus 0. 4/3 plus 1. And lastly, 6 plus negative 9. And when we combine these here, 8 plus 3 is 11. Negative 7 plus negative 3 is negative 10. 0 plus 4 is 4. 1 plus 0 is 1. 4/3 plus 1 is 7/3. And lastly, negative 9 plus negative 6 is negative 15. And that would be it there. Questions on part A? Okay. We can look at part B next. B minus A. So this will be similar to A plus B, but this time we're subtracting, and we're going to put b first. So 8, negative 3, 4, 0, 1, negative 9. This time we're subtracting from it a, so 3, negative 7, 0, 1, 4/3, negative 6. And again, just like with addition, we're going to subtract the corresponding elements. So we'll say 8 minus 3, negative 3 minus negative 7, 4 minus 0. Then we have 0 minus 1, 1 minus 4/3. And lastly, negative 9 minus negative 6. And at this point, when we subtract, 8 minus 3 would be 5. 3 minus negative 7, well, the negative and negative make a plus, so negative 3 plus 7 gives us 4. 0 minus 4 is 4. 0 minus 1 is negative 1. 1 minus 4/3 is negative 1/3. And negative 9 minus negative 6, well, the negative and negative make a plus, and negative 9 plus 6 is negative 3. So we get these two here. Any questions on anything we've done so far? Now we're going to look at C next, which is A plus C. So A, well, we can start out with saying A plus C, which is going to be the same as saying, so A, 3, negative 7, 0, 1, 4/3, negative 6, plus 3, negative 5, 4, 18. So we can go on and start adding the corresponding elements. So we'd have 3 plus 3. I'm going to drop down 1 and say 1 plus 4. Then we have negative 7 plus negative 5. Then we have 4/3 plus 18. Then we have 0 plus what? Or negative 6 plus what? What would I add to the 0 or negative 6? Is there an element here to add to it? Now, it is very tempting to say 0, but 0 is an element. It is a number that's contained within the matrix, yes? So if I actually add a 0, am I changing matrix C? Yeah. But again, as we said at the offset of this, to add or subtract two matrices, the dimensions of the matrices have to be the same. Is matrix A and matrix C, do they have the same dimensions? No. So A plus C is not possible. Because if the matrices don't have the same dimensions, it is not possible to add or subtract. And this here is the main reason why. Because we don't have anything we can actually add to 0 or negative 6 in this case without changing what matrix C is. And sometimes it's easier to see that when we actually add it out than just saying they're not the same dimensions. It's not possible. Any questions on any of these here? Let's look at the next one. Given A is this here and B is this here, find 2A plus 4 times A plus B. Now we can add A and B together because they do have the same dimensions. Now whenever we put a number out front, so here 2A, we're talking about a scalar. And scalar multiplication with matrices means we take that number, whatever it is, negative, fractional, whatever the number, and multiply with every element in that matrix. So when we talk about 2a plus 4 times a plus b, the first one, 2a, we're talking about 2 times the matrix, 3, negative 5, 0, 1, negative 4, 2, plus 4 times, so we'll write a again, 3, negative 5, 0, 1, negative 4, 2, plus negative 8, 9, 4, negative 1, 0, 3. Any questions on any of this here so far? Be ready for the next step here. Now, I'm going to write this out here for a second. You don't have to write this. I wouldn't write this because this is what we would do. This is what we're technically doing. When we do this scalar multiplication here, what we're saying is 2 times 3 and 2 times negative 5 and 2 times 0 and 2 times 1 and 2 times negative 4 and 2 times 2. Because this is what we're saying we're doing with this scalar. Now the main reason I said that most likely we don't need to write that there is because, well, I know I'm multiplying by 2. We're multiplying by that number. We could write it out, and if that is helpful for you to see it, write it out. What's 2 times 3? 6. 2 times negative 5 is negative 10. 2 times 0 is 0. 2 times 1 is 2. 2 times negative 4 is negative 8. And 2 times 2 is 4. Even if we had some fraction that we were multiplying by, we could still do that in a calculator and it would do it for us. We can do it one element at a time. Plus 4 times, well, as we've seen already, we're combining like terms with addition. So we're saying what? 3 plus negative 8. Well, 3 plus negative 8 is what? Negative 5. Negative 5 plus 9 is 4. 0 plus 4 is 4. 1 plus negative 1 is 0. Negative 4 plus 0 is negative 4. And lastly, 2 plus 3 is 5. Now we need to do the scalar of 4 for this one here. So we're going to multiply all of the elements in this matrix by 4. So 4 times negative 5 is negative 20. 4 times 4 is 16. Incidentally, 4 times 4 is 16. 4 times 0 is 0. 4 times negative 4 is negative 16. And lastly, 4 times 5 is 20. Now to end this off, to end this problem off, we just have to add these two together and then we are done. 6 plus negative 20 is negative 14. Negative 10 plus 16 is 6. 0 plus 16 is 16. 2 plus 0 is 2. Negative 8 plus 16 is negative 24. And lastly, 4 plus 20 is 24. And that's it. Questions on any of this here? Now we could have done the ones before this or this one here in the calculator. Now to do that, we have to go second matrix, over to edit. Now our first matrix is a 3 by 2, 3, negative 5, 0, 1, negative 4, 2. Now normally I will go second quit, second matrix, and then go over to B. just to make sure I don't put anything back into the matrix. Now for this here, we also have a 3 by 2. I'm going to put the other matrix in. Negative 8, 9, 4, negative 1, 0, 3. Questions on how we put those two in? We good with typing matrices in? Now, we can type it out exactly as they said. So 2 times matrix A plus 4 parentheses, second matrix A plus second matrix B, close parentheses. That's the exact same thing we got. It might save a little bit of time by typing them in, but it's always good to know how to do it both ways. Any questions on scalars and addition, subtraction? We ready for multiplication? Now to multiply two matrices, the only way we can multiply A times B, when A is an n by n, and B is an m by n, is if the columns of the first match the rows of the second. The columns of the first have to match the rows of the second for us to be able to multiply them together. The new matrix C is going to be the rows of the first by columns of the second. So these are going to be our new dimensions. So the first one we're going to multiply is A and B. Now A is a 2 by 3. B is a 3 by 1. So when we have A times B, do the columns of the first match the rows of the second? Yes. So that means we can take the product of A and B. And the new dimensions are going to be the rows of the first, columns of the second. So our new dimensions for this is going to be a 2 by 1. Now we did do some multiplication when Algebra 2, when we covered this, but I believe for the most part, y'all ended up just typing them in and let the calculator do this. Now for this, all these by hand, to multiply these by hand, the way that I remember it is we go over and down. So for our first element, we multiply over and down, multiplying corresponding elements together. Okay. So if we think of this here, so we're doing the first row, first column. First row being multiplied by the first column. So we're talking about element 1, 1. So our first number is 2, and we'll multiply it with 1. And then add to it 5 and times 3 plus 6 times negative 4. Questions on this here? So we multiplied first row with first column to give us element 1, 1. First row, first column. Now we would keep moving on because I would keep doing the first row with every column in the second. So if the other element matrix had a second column, we would go first row, second column, then first row, third column, and keep going. But here, since it only has one column, we're done with that. We move to the second row. So now I'm going to do the second row times the first column, which would give us negative 3 times 1, plus 0 times 3, plus 1 times negative 4. Then again, if it had another column, we would continue to go through this here. Now at this point, we just need to simplify. So 2 times 1 is 2. 5 times 3 is 15. And lastly, negative 6 times 4, or 6 times negative 4, is negative 24. We can do the same thing with the second row. Negative 3 times 1 is negative 3. 0 times 3 is 0. 1 times negative 4 is negative 4. Which lastly, 2 plus 15 is 17, minus 24 is negative 7. Negative 3 plus 0 is negative 3, minus 4 is negative 7. So our product is the matrix negative 7, negative 7, 2 by 1. Any questions on how we multiplied A and B? We're ready to multiply B and C. Now C is A 1 by 3. So B times C would be 1, 3, negative 4 multiplied by negative 2, 10, 1. Can we multiply these two together? A 3 by 1 and a 1 by 3. Yes. Columns of the first, which is 1, matches the rows of the second, which is also 1. So we can do this multiplication. Now it works out that our final matrix is going to be a 3 by 3. So again, just like we did with the first one, we're going to multiply the first row with the first column. And since there's only one of them, that's all we have, 1 times negative 2. Then we'll keep going. We'll do the first row with the second column, which is 1 times 10. And we'll do it again. First row, third column, which is going to be 1 times 1. Any questions on how we got the first row of this matrix? Now we're going to do a similar process now with the second row. So second row, first column. So 3 times negative 2. Then we'll do it again and have 3 times 10. And lastly, 3 times 1. And then we're going to do this one last time with our third row. So third row, first column, which would be negative 4 times negative 2. And we'd have negative 4 times 10. And lastly, negative 4 times 1. And at this point here, we just need to multiply these together. 1 times negative 2 would be negative 2. 1 times 10 is 10. 1 times 1 is 1. 3 times negative 2 would be negative 6. 3 times 10 is 30. And 3 times 1 is 3. Negative 4 times negative 2 would be 8. Negative 4 times 10 is negative 40. And negative 4 times 1 is negative 4. So our product would be this here. Any questions on these two? How I did the product of A, B, or BC? Now the last one we're going to look at is the product of AC. Well, this one here is going to be matrix A, 2, 5, 6, negative 3, 0, 1, being multiplied with negative 2, 10, 1. And if we did this product here, we'd continue the pattern over and down. So we'd have 2 times negative 2 plus 5 times, do we have another number? No. So this here is not possible. Because if we think of the dimensions, matrix A is a 2 by 3. Matrix C is a 1 by 3. Columns of the first does not match the rows of the second, so we can't actually multiply this. It is not possible. Any questions on any of this here? Now we're going to look at 2 more. And these here we can do in the calculator. Well, we could have done the others in the calculator also. Second matrix A. For example 7, matrix A is a 2 by 2, so 3, negative 4, 1, 5. Second quit, second matrix. Matrix B is also a 2 by 2. So once we get them both typed in, if we want to multiply them together, we can go second matrix A, second matrix B, hit enter, and we get our matrix. 15, negative 24, negative 24. That's 30. Negative 14, 30. So we can say A times B is negative 15, 24, negative 14, 30. Now we can do it the other way and say B is A and get 3, negative 4, negative 3, 42. Almost got it. Negative 3. So this here, we can do both products, A times B and B times A. And the main reason for that is because matrix A is a 2 by 2 and matrix B is a 2 by 2. So no matter how we match it up, the products work. But are the products the same? No. Because we're used to multiplication working, in that I could say 4 times 6 is the same as 6 times 4. It works. Multiplication is commutative. We can multiply in any order. However, as we just saw with matrix multiplication, A times B is not always the same as B times A, even with 2 by 2s. If we look at the previous ones, here, A times B will not be the same as B times A. Because for our first one here, A times B, 2 by 3 multiplied by 3 by 1. If we do this multiplication, the 3 and 3 do match. If I flip it, put B first, we'd be saying 3 by 1 being multiplied with a 2 by 3. B times A actually doesn't work. We can't actually multiply B and A. We can multiply A and B, but not B and A. So not every multiplication will work in both orders. Square multiplications will, because rows and columns are the same. If we can multiply A times B and B times A with square matrices, they will both work, or neither will work. Now there is only one case when we can multiply two matrices in either order and get the same thing, and that is if they are inverses. Because if they are inverses of each other, their products will work out to be the same. The only other one that works this way is the identity matrix, and that is our matrice with the diagonal of ones, and everything else is 0. And the little dots are just saying it continues that way, that everything else is going to be zeros, and we have that diagonal of ones. Whenever we multiply with it, it's almost the same as multiplying a number by 1. We get what we started. Second matrix. So I'm going to make matrix C be a 2 by 2 identity matrix. Oh, nope, you need to be 0, 1. So we have the diagonal of ones. Second matrix A, second matrix C, we actually get matrix A back. If we do second matrix C multiplied by second matrix A, we get the exact same thing. Other than that, we are done.